All right, what is up? Today we're going to take a look at Ghidra, Ghidrecomp, and some analysis with Python. Main goal here is to get started with LangChain, not really LangChain, but get started with some AI-assisted disassembly, file analysis, software reverse engineering. So we should probably start with installing Ghidra, Ghidrecomp, and go from there. All right, so as always, we are updating the GitHub. It's in the reverse engineering repository. We'll be focusing on the code section and the Python section and the Anger directory inside, all of that. There should be a markdown that's going to have some instructions on setting up Ghidra, and we can quickly go through this, make sure everything is hunky-dory. All right, so let's get to it. First thing you want to do is make sure you have the JDK. You can check that with Java dash version. Actually, Java dash version works as well. You'll see that in the terminal example up here. If you don't have it, this is probably the easiest way. Just sudo apt update, sudo apt install openjdk dash 11 dash jdk, or you can build it from source, extracting the tar file and editing your bash rc. You can use vi. I use nano. Once you add it to the end of the bash rc file, you can just save it and exit. I installed this using the original method, not from source, so I don't actually have this at the end of my bash rc file, but I do got some other stuff under there which we will be adding as well. So it is actually not too pertinent to make sure you have the JDK and Gradle installed, but it is going to be useful in the future in case you want to do some things with native binaries, or not using the imports automatically and using your own stuff. If that doesn't make sense, don't worry about it. But next, you want to make sure you got Gradle installed. You should see this output in your terminal. If you don't have it, it's pretty easy. It's just a curl. You do need to get SDK man. Then you just go from source, and you should be good to go from there. And finally, you want to actually install Ghidra. You're going to extract the source, and that's going to be the zip, not the source codes here, which is kind of confusing. Once you extract that, that is going to be the folder, the program folder. So I put it in my desktop. You're free to put it anywhere else. And it's going to contain a run file inside, and that is the file that you want to run. You also want to save that location because Ghidrecomp is going to need that to be able to access Ghidra. And finally, to install Ghidrecomp, it is a pip install, super simple. Once you have pip installed, again, you're going to want to set the path to the Ghidra install directory, and you're going to want that path to go all the way to the location that contains the run file. So it is my Ghidra's in about 2 different directories, so you just want to make sure you get that full path there. And once you do that, you're going to put that in the bash rc file and save it, and you should be good to run. Okie dokie. Now that we got Ghidra installed, let's go ahead and run it. Running the run executable here. It's going to open up Ghidra for us. It's going to give us a tip of the day. You can import programs by dragging them onto the Ghidra front-end manager. That's now we know that. Let's go ahead and open the code browser here. We can do that by double-clicking on this as well. That's going to open up the code browser. Give it a second, and here we are. This code browser is where a lot of the magic is going to happen. Here is the disassembled obj, which you get from the obj dump, except with a little more information. Obj dump ++. And here's the decompiled section. So you can click on a section here, which is going to be, the sections are differentiated by these star things. You'll see here. Sometimes it says function, thunk function. Sometimes it says something else, maybe main if we're lucky. We can go to the symbol tree here, go to the functions and see what we got. Main. All right, so here we are in the main. This is the decompiled main. So this is where we would normally start, and we have a graph here. We got block flow that's going to show us the blocks. Similarly, we have code flow, and that's going to show us the flow of the code as little blocks of code instead of the address name. It's the same thing though. As you can see here, we're at this section, and that corresponds 001012E3, and you can see here that is 001012E3. So there's a whole bunch of cool stuff, and the idea is we want to get some of this stuff automatic running, so we got a little bit of spider for us to get things going. So let's go through the general reverse engineering process. Let's try and solve this CRACKME and see what we can do. All right, so here we are. We're gonna do a little revenge here. So if we go back to the file that I have in the GitHub for y'all, the view file info is going to be where we're going to do some of the static stuff. We're going to run the file command, the strings command, the readelf command. We're going to get a hex dump, and we're going to disassemble, which is also going to give us a hex dump twice. So we're actually not going to run xxd. Obj dump, in my opinion, gives a better hex dump, actually. xxd is going to allow us to edit the obj dump, edit the hex dump, if you need to, but in this for CRACKMEs, we're not going to need to. So that would be the reason to use xxd over objdump for modifying the bin file or the executable or whatever has the binary stuff for messing with the hex data. Okay, so pretty cool. We can actually just run this all in one fell swoop, as I've done, and we get the disassembled here. It's going to come out. We get the file headers, and we get the file info. Obviously we have the file name and the strings. All right, so generally we want to figure out what type of file it is, and we can do that with the strings command, or actually I'm sorry, we can do that with the file command, get the file info, and we can see that it is an ELF 64-bit LSB Pi executable. We have the ELF format and the PE format. The ELF format is gonna be helpful for Ubuntu stuff. The PE format is going to be not helpful for Ubuntu stuff. We're going to have to use WinDebug and all the other Windows tools. So we're going to stick with F just so I can stay in ELF, so I can stay in the Ubuntu environment. So once we figure that out, we are good to run the objdump and whatnot, which is why in the code you'll see a check for ELF, and then if it's not, we'll have to do something else. I haven't included that yet. We see the files, that's where we start. Then we can go to the file header, and that is going to give us the entry point, and I guess you can see that it's little endian 2's complement. So when you are looking at the hex dump or anything with values, you're going to read those numbers a little bit differently. Generally, this is Ghidra's going to take care of that, so you don't really have to worry about it. So that is good. Then we can check the symbol table here and see what kind of symbols we got. So we do have a main here. We have a check password function, a couple other useful stuff, and we can check the strings, and we can see here that there is a check for an incorrect password and there's a check for a correct password. There's a place to enter the password, something for obfuscating the password, some main, and some other headers. There's obviously a text section, a data section, and whatnot. So that is pretty much the information we can get from here without going into the disassembled portion, which is where the fun actually begins. So we've determined that it's an ELF file. We're ready to start using Ubuntu tools. We're going to look at the obj dump, and this is where we begin our analysis. So the general procedure is we'll start with the disassembled. We'll just get a quick idea of where things are going. We can then either go to GDB or Ghidra and get some more information. In this case, we're not going to do GDB because the video is about Ghidra, but GDB is pretty helpful because it'll allow us to step through the program and see the values as they come up. We may actually be forced to sneak some GDB in. So we're going to start in the main because we were given one. We got lucky. This is the start. This is where the entry point would be. So that's the text. In the main, here we are. We go down, we set everything up, we put some space aside, and we move this. It's a Q word, so that's probably something important that we're going to move into the RAX, and we're going to take that value and move it somewhere into memory, or actually we're going to move it above the base pointer, so we're going to move this somewhere on the stack. We're going to set EAX to 0. That's what, if you XOR something to itself, it's going to set it to 0. And we're going to call something here that's going to print something. Going to keep going, do some moving. We're going to call something else. This is going to take in some input. We're going to keep going. It's going to put that value in RAX, and then it's going to move that into the RDI to free up RAX, and then we're going to check the password. When that's done, everything that's returned from a function will go into the RAX, and RAX is just the 64 version of the 32 version of EAX. So we're going to then test EAX, compare these. If they're equal, we're going to jump somewhere in here, which is going to bring us down here, and we're going to load this in here. We're going to call this. We're going to put something on the screen, print, and leave here. Okay, and if they are not equal, we're going to go down here and we're going to call again. I already said that. And we continue. So it looks like we are going to do some checking of a password. We are going to be doing some input, and we're going to see some print stuff a couple times. Otherwise, we have the check password here. When we go in here, we're going to set things up. We're going to move what was in RDI, which we found down here. That was something in memory, is going to go into RDI. So we're going to take that thing out of memory, take a quick look at it. We're going to set the EX to 0. We're going to move this address into RAX, and we're going to then move that somewhere else on the stack, do some more moving, and then we obfuscate the password, and then we do a string compare, and it looks like we put that in RCX. We put another, this I think was the original from the argument that we had up here. We're going to put that into RCX, or actually we're going to OR them. Okay, XOR them. So we're going to try and see if they are equal, and if they are, we're good. We leave. If they're not, we go here, something failed, and I think we skedaddle on out of here. Okay, that looks pretty good. Now we want to go to the obfuscate password here. Okay, looks like we have some other stuff going on here. We're going to do a jump, and we're going to move some of this. We're gonna move this and extend it, take it from 32 to 64, and we're gonna put this value on the stack in here, and we're going to get the string length. We're going to compare, try and see if the string lengths are equal. If they're not, if the RX is below the RBX, we're going to jump to 1203, and it looks like there's a loop. All right, so we're going to come back down here, keep checking them. Looks like we're going to iterate through the string for some set number, and once that's done, we're going to add the value of 40 to RSP, or 28 in hex. Then we're going to pop these off the stack and get on out of here. We have something going on here. In the main, we are going to set up we're going to, save the password that it looks like we're entering in a password. It's going to save it, then it's going to check it. And when it's checking it, it's going to do some tricks to obfuscate it. That's a nice name for us, so we know really what's going on. It's going to do something to change the values, and it is going to go into a loop and perform some operations for the length of the string, it looks like. So that is just a quick idea of what's going on here, just so we kind of know what's happening. Let's check Ghidra to confirm that, and you'll see that this is going to really breeze things for it, make things a lot easier for us. So let's open up Ghidra. All right, so here we are back in Ghidra, and you can see that we have the disassembled portion here. This is like the obj dump we were looking at. And we got the decompiled portion here, which is a little bit easier for us to read as human beings. So here we are in the main. Remember, we did have the check password section here. We can click on that, and it's going to take us to the decompiled check password function. We can go here and see that there are 4 variables local, and then it calls the obfuscate password function and does a string comparison. If the local 10 here is not equal to the local 10, actually, then we get a fail. So in this case, we should, I guess we don't get to see that, but we can check the obfuscate password here, obfuscate password function here, and we have a loop, as I suspected, a while loop. This is going to be the length of the string that gets passed in, and if that is less than or equal to some local, which is 0, I guess this is just going to increment. Maybe we can, yep, and it looks like we do an increment here, and it looks like we take this, the string here, it's a car string, we take, we start at the first value, and it looks like we raise it to this, which is 16 times 5. That is 80 plus 5, maybe. It might be, it might not be. 16 times 5 is probably 80, and 80 plus 5 is 85. Yeah, so that's 85. So it looks like we do a little math here, and we do that for each character until we get to the end of it. It looks like we just do that for each character. We perform the same operation and go on from there. Now, that is good to know. That tells us what we need to know. But what values do we want to pass in? For that, GDB is just going to make things a lot easier. We could get out the pen and paper, go through here one by one, figuring things out. I think we're just going to open up GDB because we might as well get some practice with that as well. So that is GDB. That is Ghidra. The Ghidra portion. The best thing for the most useful thing is to see the decompiled. It's a little more readable, and we can see the graph flow here. That's just going to show where the jumps happen. If we get a good jump, we go here, and if we get a bad jump, we go here. Also useful, given the simplicity of this main function, we don't really need this. But when things are extremely obfuscated, especially if we don't have a main function, this view is actually quite helpful here. So let's actually guess we can. Opening up GDB will take us home. Ghidra is what we have here. We have the decompiled sections here. We do use Ghidrecomp, and you can see that that's going to just give us those decompiled C files in a folder. So we'll go into the Python, Anger, the Ghidrecomp bins, and here, and you can see that we get all of those. So we can we get the main here, we open it up, that's what we see, and we can pass those through ChatGPT to help us understand what's going on. So we can use GDB or we can use GPT. So what are we going to do? Let's use GDB first real quick, and then we'll go to GPT and see if GPT can do it on its own. All right, so let's get started with GDB real quick. GDB real quick. You want to make sure that you have permissions. So LL, if it's not green, then just cmod 777 and the file, and that'll give you what you need. So first thing, let's open up GDB. I'm using Jeff. It gives us some extra stuff that's fun to look at. We want to load the file, and you do that with the file command. So file, and then the file you're trying to examine or step through. There's no debugging symbols, which means we're going to be doing this purely in assembly. We're not going to have any access to the C, so things are going to be a little bit different. You want to make sure that you go instruction by instruction, and you'll see what that means later. We'll go ahead and start, and that's going to bring us to the beginning of the C. And the beginning of the C happens to be inside the main for us because we got lucky. So we have our registers here, we have our stack here, and we have a portion of the disassembled file here to kind of give us a reference of where we are. We can disassemble to see the full section that we're in, and we can backtrace just to confirm that. So we are in the main here. What I'm going to want to do is put a breakpoint at each function. We have a print, a scan, and a check password. So actually, we can just go to scan. We'll copy the scan. Well, we'll just do it right. We'll start at the print here. Copy this. Break the star. Lets it know that it is a memory location, and we'll paste the memory address. That is what these values are. Hit enter. That's our first breakpoint. Star here for the scan. Copy. That is our second breakpoint, and we will scan here. That is our third breakpoint. So let's go ahead and next. Next is going to go in reference to C. Really, I can just hit continue, and continue is going to go until the end, or until we reach a breakpoint, which is what's going to happen. So we'll hit C, and we're at a breakpoint. We can look at the stack, and we can see that there's some paths here. There is this in RDI, which is probably what's going to get printed next. I'm just saying probably to keep things open. That is definitely what's going to get printed next.
Then we'll go ahead and continue again, and we are at the scan. So we can disassemble, and we can see here that the printf function was called. This was loaded into RAX. RAX was moved into RSI, and we can see here those things. This value is moved into RDI. To kind of say that it's expecting a string, I guess it's 19 characters. And
we are at the scanf portion, so we'll hit continue again, and here we are. Now we are printed and ready to scan. We're going to go test pass. Since we don't know what the proper password is, we'll go ahead and hit enter there, and that put that in R9. It took out the enter. It understood that that was not needed, and in RAX we have the value, the password that we've entered. We'll disassemble, and now we are at this portion here. So we want to go inside the check password function, and to do that we will step I, or just SI, to make sure that we step into the function in assembly. So SI, now we are in check password. We can backtrace here, and we'll see that we are in check password, which is in the main, which is where we want to be, and we'll disassemble to confirm that. So in the stack we have test pass, which looks pretty good.
And we will hit next again. Actually, next I. There we go. We're still setting up the stack for this function. Next I again. Okay. And next I again. Alright, nothing interesting. Next I again. We're going to move this into RDI. Next I again. And we can see that the value in RDI was moved into there. What's in RDI is the test pass. So we did move that in there. And we should see, and we can't access that. So we're just going to have to on faith trust that that is something important. Next I again. We're going to set that to 0. Boom, it's 0. And we're going to move that absolute value into RX again. Okay, now we have this weird string here, which is something strange, and we do remember that these are all going to be manipulated some way, so we'll step again. And we'll step it again, next again. Next again, next again. Okay, looks like we added something there.
Next again. Okay, now we have test pass, this weird value here, and we're in the obfuscate password. So we want to step into that, and we'll backtrace just to make sure that we're looking good here. Okay, so we're in obfuscate password, which is in check password, which is called by check password, which is called by the main. Cool. We'll disassemble, and there we are. Now we're in here again, and we will next I. Okay, we have this value and test pass. I would guess that these something is going to be obfuscated here.
So, let's next I. Okay, next I. Nothing too interesting, next I. Let's see if anything happens to RSP, next I. From there, okay, then something in RDI. This value's going to get moved. Alright, next I. Okay. Next I. Alright, now we're going to jump. And let's see, next I. Okay, we jumped. Now here we are, next I. Okay, so it's here. Next I. Remember we started out here, so it's not the end of the world. Next I. Okay, now we're back, we have it back. Next I, we're going to get the length of the string here.
Next I. This should, okay, it's A. A is
The value 10, so it looks like we want a string with a length of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that is 10 characters. And we're going to compare our BX, which is 0 to RAX, and that is where the looping happens after this. Next I is below that, so we should jump. Next I, okay. Next I, alright. Next I, next I. Alright, here we are. Now we're going to next I here. Next I here, 3D. Okay.
boom, we put it back. Next I, and now we're going to XOR. So something interesting is going to happen here. Something should
change. Next I. And we're going to move this. Next I. Okay.
Next I. Okay, good. Now we have an H. That changed to an H. All right, let's see what happens. Next I. Next I. And then we're going to do this all again. Now we're at 1. We're going to have to do this 10 times. So I'm going to disassemble, and good. So something changed right around here. I'm going to put a breakpoint there. Break star here, and I will next I. Next I. Okay, next I, and we'll just hit next again. Okay, now we're here at the breakpoint. Next I. E. Okay, so now we've added an E, and so now we have HE. Okay, let's see. Then we'll hit next again. We'll try and get back to that. Cool. Now we got rid of both of those, and now we're here. We're going to raise this, do that funky stuff to it, and we'll see what happens. Next I. L. So that turned into an L. 9 is going to correspond to L. So we should have 2 L's, and we'll see what happens. We'll just hit next again. Okay. Next I. Here we are. And now we got another L, as we can see here. Next. And here we are. Next I. Oh, we got an O. Next. Next I. W. Next. Next I. O. Next. Next I. R. And I guess you can guess where this is going. Next. Next I. L. And I'm going to guess 1 is going to correspond to D. So next. Next I. D. And then we can next I. Next I. And now we have hello world and test pass. We're going to move a portion of that into RBX. Next I, and they should be equal here. So next I, we have hello world. Next I, it's gonna look for the string length. It should be 10. Next I, okay, and it's not below, so it's gonna skip that. It's not taken. Next I, and we should escape out of here. Next I, we popped all those values. Hello world is an RDX. Next I, hello world is also an RDI. We're still let's disassemble real quick just to, okay, so we're in here now. Okay, next eye. And now we have test pass. Okay. And next eye. Okay. Just gonna move it into RDI. Okay, and then we should be checking RDI and RSI.
We're gonna do a string compare, RDI and REX. They're obviously not equal, so next eye, next eye, next eye. Then okay, Zor, RCX. It's that. Next eye.
So it wasn't equal, so we skipped that. We got to this, it failed, and we're gonna leave here. So next eye. All right, and we should return back to the main function. Next eye. Look, we are in the main function. It's gonna test, and it should fail. Next eye. They're not equal. Next eye, because it should be 0 and it wasn't. So all right, so we failed that, and it should print this value. So it was looking for hello world. We put in test pass. The password was incorrect. Next eye, and we can just go ahead and hit N. We'll hit continue, and it exited normally. We skipped the print, but it failed. So it does look like hello world is what we're going to want. So let's go ahead and start again. We'll go ahead and continue. We'll continue again, continue. Oh, whoops. And we'll type in hello world. I did mess that up this. I'm not sure. All right, it did take it. And then let's continue, and let's continue, and let's continue, 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 continue. Ah, cool. So we got it. Pretty easy. All right, so that wraps up installing Ghidra, getting Ghidrecomp in, and doing a quick run through of the reverse engineering, solving a CRACKME process. Next video, we're gonna go ahead and try and automate some of this. Try and see what help we can get from some large language models, and try and see what help we can get from the view file info code that is on the repo. So go ahead and check that repo. There's a bunch of other files in there that's going to give you a preview of what's coming next. If you have any questions, please comment. I know this was kind of a breeze through, but just something to get us going. So this was part 1. I hope you have a good Saturday or Sunday or whatever day it happens to be in the future. Peace and health be with you.